I'm going to show you how to do the second part of the Newton's second law lab. To start, I'm going to set up the KET dynamics program the way the lab describes, and I'm going to turn the brake on, drag the cart to the very beginning of the track, to the starting point. Now I'm going to add 200 grams to the cart. And it turns out this little window down here tells you what's going on. So I can see that if I hover the mouse over the hanger weighs 50 grams. And if I hover the mouse over the cart, it says the cart weighs 250 grams, but that I've added 200 more. So that would make a total of 450 grams. So the cart has a mass now of 450 grams, and the hanger has a mass of 50 grams. Now let's take a look at that analysis. To calculate the theoretical acceleration, I start with a formula that says the hanging mass times the gravitational constant is equal to the hanging mass plus the cart mass times the acceleration. And then I can plug in. It turns out I really should change the masses into kilograms. So this is 0.050 kilograms for the hanging mass. That's 50 grams times 9.8 equals the 50 grams, or 0.05 kilograms, plus 450 grams, which is 0.45 kilograms. When I add those together, oops, I have a slight error here. This should be 0.05 kilograms instead of grams, and then this one should be 0.5 kilograms. When I finish, though, I get the same answer with grams or kilograms. I end up getting an acceleration of 0.98 meters per second squared. I guess I'll just box that in. So that's my answer for the acceleration theoretical. Now we're going to actually do the experiment. And to do the experiment, all we have to do is, we've got the thing ready to start. We have to turn the sensor on to gather the data. Then we have to click go or break off. Either one would work fine. And then I have to turn the sensor back off again. So I'm going to turn on the sensor, click go, wait till it gets to the end, turn the sensor off. Now I've collected my data. And you can see the graph here is position versus time. And you can see the position didn't change at all. And then as soon as it started to move, this upward motion here represents the motion of the cart along the track. And this represents the time that passed. So the longer the cart moved, the faster it was going, because it went up faster for the same amount of time. Now we're going to recreate this position versus time graph in Excel. So to do that, first thing I'm going to do is just click on here and say copy data to clipboard. Now I'm going to go to Excel. I'm going to open a brand new Excel file. Let's see, new blank worksheet. And I'm just going to paste the data in. Now that I've pasted it in, you can see, well, it looks like maybe I could use a little bit less significant figures. So I'm going to highlight this data and mess around with these two buttons. And by clicking them a few times, you can get two significant figures. Now down at the bottom, there are three. That looks pretty good. Now, I guess the next thing I'd like to do before I make my graph, I'm just going to, I want a title on top of these. And I pasted them in the very beginning. But if I highlight these top two rows, right click and say insert, now I have a little bit of room at the top, and I can type here time and position. And the time is in seconds, and the position is in meters. Now you can see it looks a little bit awkward, so I'm going to highlight A and B, and I'm going to make those center. Now that doesn't look too bad. Now, to make a graph, I'm just going to highlight A and B, go to Insert, and it's very important that you choose not line graph, but choose XY scatter plot. And when I choose that, I'm just going to choose just points, and there's my graph. I'll make it a little bit bigger. And now to paste this graph into your report, all you would do is right-click and say copy, go into your word processor, and right-click and say paste. And then you'll have that you'll have that chart in your report. But oh, I'm not quite done yet though. Before we paste it into the report, I'm going to call this, I'm going to say position, I'm going to give it a title. Position of cart. I'll just call this chart number 1. And the lab report also said to give it axis title. So I'm going to say primary x-axis title, delete all this stuff, is going to be time, and that's in seconds. And then the y-axis title, again, add chart element. The vertical axis I'm going to put in here, delete all this, I'm going to put position, and that is in meters. So we've already got great units. We've got in the MKS system, we've got seconds and meters. Now we're all set. Now we would just copy this and just paste that into whatever report you're writing. All right, next. Now, when we move down, we finished that section, but section D says we want to make a position versus time squared graph. And to do this, what I'm going to do is right-click, and I'm going to copy this whole sheet so that we still have this graph. So I'm going to say right-click, move or copy, click create, the little box that says create a copy, and say OK. And now we have 2 of these. We have 2 that are identical. And in my new one, I'm going to go to the next step. Now, if you look at the data, you see how initially the position didn't change? You can see that on the graph. The position didn't change initially, and then it started to move. So when we look at the positions are really boring. Nothing's changing all the way down to right here. The lab says, go to where they start changing and highlight all the values as they change. And then look what happens though when I go too far. They're all the same again. So that's when the thing hit the following end. So we want just the part where the cart was moving freely. Just that part. The lab says right-click on that and copy it. And then go back up to the top. And right here in cell C3, paste those values in. And also, it also said to delete this. We don't need this chart. Remember, we have the chart still in our other tab, but in this tab, we don't need that chart anymore. Now, I'm going to show you a couple tricks. The mouse has 3 functions in Excel. If in the sheet, if we see the white cross, we can highlight a bunch of cells. When we highlight cells, we then can do stuff to them. In this case, we have another function, though, which is if I highlight some cells, like for instance, I want to move these cells. If I highlight them, I can actually grab the edge and I get 4 arrows. When you see the 4 arrows on the mouse, that means we can use it to move those around. Oh, I don't want it over there, so I'll undo that. What I want to do is just move it right next to it, right there, because now the position is in the 3rd column because I've actually copied the data over to there. And my 2nd column is now I'm going to get rid of it because I've moved the important data to the 3rd column, C. I'm just going to delete everything in this column. And then I'm going to make this column time. I could write squared, but I'm going to say time hat 2. And the units for that are seconds squared, or second hat 2. There is actually a fancy way to put superscripts in, but just calling it hat 2 means squared, and that's perfectly fine. And then we're going to put a formula in. This is very simple. We're just going to type in equals the one to the left. We're going to say we're going to make this cell that I'm typing in right here equal to this cell squared. A3 squared, enter. And now I'm going to use the 3rd tool of the mouse. You see the white cross, you see the 4 arrows to move things around, but if I slide it over here, it turns into a small X, a black X, and that's the copy tool. If I hold down the mouse, I can copy that formula down and fill it all in. And now the formula has put time squared into all those slots. So that's great stuff to work with. Now what I'm going to do is highlight the data that I want to graph. These 2 columns will work. Insert, again, it's very important to choose a XY scatter plot. And I'll make this a little bit bigger. And now we're going to do the same thing we did before. We're going to give it a title. Position, I'm going to say position of cart, chart number 2. And for the second one, we'll add our X label, or Y, let's do our vertical label, which is our Y label. Our vertical label is going to be still the same, right? Position. And that's in meters. And our X label, our axis title, our X-axis title on the horizontal axis is going to be time squared. And that's going to be, I guess I'll write it out this time. Time squared, and that's in seconds at 2, seconds squared. There, now we have our graph. Now let me just look at the directions. So we've found the data that was really important when the cart was moving. We squared the time. We made our new graph. And the next step is, where are we at now? We are at step 30, which is to add a linear trend line. So I'll right click on the data, add trend line, and it says linear, and I'm going to add the equation to put it on the chart. And there's the equation. And now I guess what I'll do is I'll make that a little bit bigger, the equation a little bit larger, and maybe make it bold. And now that's the equation of this straight line. But this says y equals this number times x plus a constant. But take a look. What is actually on our y-axis? The position. The position in this case is actually along the x-axis, is the way the cart was moving. So in this particular graph, even though it sounds strange, our y-axis represents the position of the cart along the x-axis. And our x-axis represents, rather than just an x, our x-axis represents the amount of time squared. T hat 2. So that's our new equation. X position of the cart is equal to a constant value times time squared plus plus a value of a constant value. Now this is a little strange. It's not quite the result I expected, but let's see how it comes out. I think my computer is running a little slowly, and I think that the cart isn't working quite the way it's supposed to. But let's just do the analysis and see how it turns out. Maybe I can do another video in another day when things are working a little better, but let's see how it looks. So I'm going to start with the equation that's given for the slope, and I'll paste that in here. You don't have to do this on your report, but I'm going to do it here just to show you how it works. We have our equation for the line. I'm going to paste in the equation for slope and maybe make that a little bit bigger so we can see it. Slope equals, I don't need that cell so wide. Oh, this is inside a cell. Huh. Should be able to do this. The slope equals 1/2 the acceleration. So in our case, the slope is, let's just type our equation in, get a little bigger. Our slope is equal to, I guess I'll put it right in the cell, equals 0.5708 is equal to, in this equation, I guess I'll just type it in this way. Whoops. That's equal to 1/2 of the acceleration. So when I do the math, you can work that out. Really, all we do is multiply both sides by 2. So I'm going to take that same number on I'll just see what it equals. Equals 0.5708 times 2. Multiply both sides by 2. Slope times 2 is 1.14. Well, what was our theoretical value? 0.98. Not terribly bad, but not as close as it should be. But anyway, I think I did the work right. I think there was just my computer might be a little slow.